Okay, so a kid is sledding down this hill and they get this push, right? So it's like, let's draw a picture of this. All right. And they get a push. They start at rest, and we give them a push of 78 newtons for 3.7, right? And we assume that this push is speeding them up, right? So here's this child, which I'll represent with a nice rectangle. Okay, we give them a push, and the hill is 2.7 meters tall. So let's draw a picture of that. This is 2.7 meters tall. And we want to know how fast they're going when they're at a height of 1.1 meters. 1.1 meters. They're moving. Okay, now these are the things we can know. Force times distance, mgh, 1/2 mv squared. Okay. On the left side, I'm going to maintain that it starts from rest, so there's no kinetic energy. But there is a force times a distance speeding us up, and there is potential energy to start with. So on the left side, I'm going to say force times distance plus mgh, okay? Now here, this is the right side, okay? Well, there's no more force. We're neglecting friction, so there's no force slowing us down. This thing has potential energy, and they have kinetic energy there because they're not at the bottom, okay? So they have potential and kinetic. So it's mgh plus 1/2 mv squared. Okay, now we're set, right? So our force times distance is 78 times 3.7. Our MGH is, let's see, 26 kilogram kid, a small child. 26 times 9.8 times, what's our height? 2.7. Right, and then that equals the same kid, 226 times 9.8, and then our height is now they're at 1.1 meter, right? Okay, and then, whoops, plus, that's a plus, not an equals. Okay, 1/2 times 26 times v squared. Seems like we solve for v a lot, you know? It's because we really care about how fast stuff is going, right? So force times distance, so work plus kinetic or potential turns into potential plus kinetic, okay? So the entire left side, if I do this, 78 times 3.7, okay, plus 26 times 9.8 times 2.7. The entire left side here is 976.56. And then this term here, 26 times 9.8 times 1.1. This term here is 280.28. Plus 1/2 26 v squared. Okay, so now I'm going to go this minus this. So the 976 guy minus the 280, that's 696.28 is 1/2 26 v squared. All right, so take that number and multiply by 2 to get rid of the 1/2, divide by 26, and I get that 53.56 is v squared, and then I'm going to square root both sides, right? So second square root, second answer. And I get 7.318, so 7.32 meters per second. All right.